This conference will now be recorded.
Basically, we try to go in depth to dig through technical stuff that you come across in your career. All right. The last one we did was on cloud computing, and I believe so many of you learned something from it. Some of you would have heard of API, probably not everyone. Not everyone, but that said, there is a lot of application.
We cannot hear you. We cannot hear a word.
Is it? Hello?
Can
anybody hear me?
I can hear. I can hear you clearly.
Okay.
I can hear David loud and clear.
Okay, we are recording this, so anything that you can't hear, you can replay at a later stage.
Someone is trying to join and finding difficult. Before Paul starts, if George cannot hear me, please let him. Someone help me to send me a message to probably log out and join back. What I was saying is that these trainings, this tech talk, is basically to go deep into technical stuff that you come across in your career. API has enabled several products that ordinarily would be impossible to develop from scratch. All right. So Paul will be taking you guys through the workshop today. I'll be listening. I also have our developer in-house, Solomon. He has also worked on APIs. So if he has anything to contribute later on, he will contribute as well. And if I need to come in like last time to add any further explanation or example, I will do that from time to time. Please hold off on your questions. Have a piece of pen and paper. If you have any question, put them down. Once Paul goes through the, you can come back and ask questions. Please let's not break or ask question in between. Just take a note and then you ask the question at the end. Okay.
Thank you, David.
All right. Paul, it's up to you now. I'm going to also turn off my camera. I don't know if you guys want Paul's camera to be on or not.
No.
Okay.
Anyway, hello, good evening, everyone, and thank you very much for joining us today. My name is Paul Tethy. I've been in the IT industry for over 20 years. I won't say how much more, but it is over 20 years now. And I am going to take us through APIs. So let's start that. So the agenda for this evening, or for the next hour, is to describe what an API is, tell you about the different types of APIs that are out there, and then go through some examples and try and highlight the importance of APIs, how they contribute to the economy and managing APIs. And throughout this talk, David Agaber and Solomon will jump in to give and share their experiences, but as David said, please hold off on your questions until the end. Thank you. So an API, what does API stand for? API stands for Application Program Interface. Basically, it's a software that speaks to other software, and it allows these applications to speak to each other, and they don't even have to have any knowledge of each other. API is pretty much, it resembles SaaS or software as a service, because the software developers don't have to start from scratch every time they write a program. They can just write a program that will talk to an API. So instead of building, let's say, one big application that can do everything, they can create the same application but spread it out into what is commonly referred to as microservices, which will communicate over an API type interface. So an API is basically a piece of software that allows an application. In this example, I've given your app, so it could be your mobile application, and it will send a request, which is made up of various parameters, and that will talk to another application to retrieve data back to display in your app. Could I ask anyone that's not on mute to go on mute, because there is some feedback that I'm getting. So to put it short, an API allows two or more applications to communicate with each other to exchange data. So like I said, when your app sends a request, so if we send that, it will pull back the data and display it on your application.
Paul, can I come on?
So,
can you go back to the
can.
previous slide, please, Paul? Let me just say something there. All right, so I'll give you guys a simple example. Imagine you walk into a restaurant. That is your app. You walk into a restaurant, okay? And their app will be the kitchen, the chef. In between the chef and you, there are waiters, okay? You send a waiter your request. For example, the meal you want. The waiter takes that request to the chef prepares the meal and then send it back through the waiter to you. All right, that is exactly what API does. Just imagine API as the waiter between you and the kitchen. Now, for every application you go on to, like Facebook, for instance, you might not be aware, each time you make a request or you click on somebody's, you are scrolling through videos, you are making requests, whether you know that or not, or you are scrolling through your through the feed. As you are scrolling through the feed, you are making requests through the database, and the database is returning a result. That is what you see on the interface. That's my contribution, Paul.
Okay, thank you. There are some more examples further in the presentation, which we'll go through. Okay, so there's different types of APIs. You can have local APIs, program APIs, web APIs, and other different kinds of web services, stuff that you can look into later. But in short, a local API, well, is the original form of an API, which is the operating systems API that provides services to applications and programs, which are sort of like a front-end graphical user interface, which will ask for data from a database, which is held locally. Then you got the program API, which is based on remote procedure calls, and that sends a service, sends a request as we've described to another program, and that'll pull back the data. And then you also have the web API, which is also known as a web service, and that's an application that will communicate to another application via the World Wide Web. So there's many different types of API out there. The ones that you'll be more familiar with or interact with the most are going to be things like the web APIs. So on the previous slide, sorry, let me just go back. On the previous slide, we mentioned two types of web service, SOAP and RESTful. So what is a SOAP web service? So SOAP web service describes the it's a basic standard way of integrating applications that are on the web using XML. So to open a gateway or protocol to another application. So it opens up like a tunnel to another program or another server. XML, which I'm sure, or I hope many of you are familiar with, is a common markup language, and it's used to tag the data that you're putting back. And SOAP is a simple object access protocol, which is used to obtain and transfer the data. Sorry? And then we have WSL, Web Services Description Language, and that is used for describing the services available. And then you have the Universal Description, Discovery and Integration, UDI, which is used as a listing service as part of this web service.
Click on video.
Sorry, if you're not on mute, can you go on mute, please? So a SOAP web service allows different web applications from different sources to communicate with each other without time-consuming custom coding, because all the communication is in XML. So web service is not tied to any one operating system or programming language. So you can have something like C#.
Excuse me, Paul, the noise is too much. I can't hear nothing. I can't hear anything.
Okay, I can't speak any louder. There must be something wrong with your speaker.
No, I'm not talking about my speaker. Some people, their mic is not on mute.
Right, yeah. So
yeah, I think it's Miriam. It's Miriam.
yeah, so can everyone go on mute?
Miriam, please go on mute. I'm trying to find. Okay, I've seen. I'll mute her now.
Yeah, okay, thank you.
1 second.
Can you mute everyone?
If I mute everyone, you'll be muted as well. That's why I didn't want to do
No, but
that.
I can unmute myself.
Yeah. All right, let me mute everyone. Therefore, you'll mute yourself later. Paul, please unmute yourself now.
Can you hear me?
Yeah, it's better.
Right. Yeah, that's better. Thank you. Okay, so just to repeat that last one. So this slide here is just showing us what a web service or SOAP web service is. And so web services allow different web applications from different sources to communicate with each other without time-consuming custom coding, because all the communication is done in XML or extensible markup language, which is used to tag the data. And the because of this, the web services are not tied to any one operating system or programming language. So for example, there we can have a Java application can talk with a Perl application, or a Windows application can talk with a Unix application because of these services. So to give you a little visual example, you can have application A. Again, this could be your restaurant, and then application B could be the chef or the kitchen, and then the request still goes using those web services, and the data is still returned as well. So that's it. So what is a RESTful web service? Well, that's the other example that we were given there. So RESTful stands for Representational State Transfer. web service. It's also referred to as a RESTful API, and it's based on the REST technology, which is a web application that uses the HTTP requests to retrieve and post the data to its database or application. It's one of the more preferred technologies that's in use at the moment, and it's more robust than the SOAP API that we were just talking about. As more and more companies are using the cloud, the APIs are being exposed more, and REST is the preferred choice, or in this case, logical choice, for building distant APIs to allow applications and users to connect and interact with the different services that are available on the cloud. Again, using a simple diagram, you can see how the same app A and app B can communicate in the same manner, but just using the RESTful web service. So what we've done here is just given a couple of examples of what an API call would look like when passed it through a web browser. So if you can imagine that you have a single field where you want to find the word Joe or the name Joe. So this URL here is using the HTTP protocol, secure link, and it's going to a specific URL. Oh, sorry, let's go back one. It's going to a specific URL. And then in there, it's going to search for these parameters. It's going to look for all of the fields which have the name Joe in them. So that is the request that will go off to the server. And then when the server returns the results, it will send it in a format which can be displayed on the web page. And that will list out all of the records that have the name Joe in them. Likewise, if you wanted to narrow that down to find all Joes who are 17 years of age, we can use the same request but add an additional parameter using this comma to return everyone whose name is Joe and has the age equal to 17. And again, that will then return the result of all of the people that are named Joe that are 17 years of age. So it would be a slightly different, more refined result. Another example I would give to that to make it more simpler is if you're looking at a spreadsheet and you have rows and rows of data in there, and you want to find all of those rows of data that have the name Joe in it, you can do the Control F function. And what that will do is that would look up, using that query parameter of Joe, all of the cells in that spreadsheet that have the word Joe in it, and it will highlight them. So it's a similar sort of mechanism, but obviously on a more complex scale. So these are some basic REST API examples that return, like I said, specific results. And you can use special operators for more advanced queries. And I've given a couple of reference links at the end of this presentation, which we share, so that you can find more examples of these and how they're used in the real world. Okay, so we've gone through, we've looked at REST and we've looked at SOAP. So what's the differences? What's the best one to use? So with RESTful web services, they're stateless. So that means that you can test any condition and you can restart the server and check if the interaction survives, which means it's more robust and flexible. So most of the servers out there use RESTful web services, and they provided good caching infrastructure, which means that once a request has been made, it will hold that response in a state. So if the same request is made again, it doesn't have to go forth and pull back that query because it already has that data stored in its short memory. It's also useful for restricted profile devices such as mobile phones and tablets. And they have the additional parameters are reduced. So we have the headers. And REST, it doesn't enforce any message formats such as XML, JSON, whereas SOAP is XML-based messaging protocol. So it allows it to be a bit more flexible.
We'll stop it there for now. Interview terminated at 21:57. Thanks, Yasmin.
Omi, can you
please go on mute?
I'm useless.
Oh, Paul, I'm going to mute everyone now. Then Paul, you unmute yourself back. Please unmute yourself, Paul.
Okay, so we're back. I'll keep my mute button there.
All right, thanks. I'm back on mute.
So the SOAP web services, web services description language, or WSDL, it describes a common set of rules that define messages, the bindings, location of the service, and it's akin to a contract to define the interface that the service offers. SOAP requires less work or less plumbing than REST, so that transactions, that means that transactions coordination are trusted, and a lot of the applications out in the real world, although they're not simple and don't support complex operations, the SOAP approach means that the developers don't need to write additional code in order to support that service. So SOAP itself supports several protocols and technologies, including WSDL, XSDs, and WS addressing. So we've got some examples of APIs in use in everyday life, which you would have come across. So Google Maps API is one that's heavily utilized by developers around the world, and Google Maps Google allow developers to embed their Google Maps into web pages. So if you've ever gone to a website and you've gone to the Contact Us page, for example, you'll often find that there's a map depicting where they are in the world, and that is often provided by Google Maps. In fact, the large proportion of them are provided by Google Maps, who allow developers to use their API to embed that image and location onto their websites. YouTube is another popular one that's used, and you'll often find that also embedded into the Google's search results page, and that allows them to integrate the videos and functionality of those videos into the search results page or into websites or other applications. Flickr is another one. Twitter is obviously a more popular one as well. And then you have Amazon product advertising, which is quite an interesting one because it allows the advertisements of goods that Amazon provide to be embedded in different search engines, on different websites as ads, etc. So you can see APIs do play a huge part of how the world works and how e-commerce is done. Another real life example would be if you go to any media site where they're presenting articles about latest topics in the world today, you'll often see little ads popping up in between articles, and they're served by APIs. So the importance of APIs is they're considered vital tools for most businesses. A lot of companies build their applications and services and, of course, their infrastructure on APIs, and that's pretty much what we start talking about when we start referring to microservices. It's little pockets of programs that will perform a simple function that will talk to another program or application that performs a different function, and they'll communicate over an API by sending requests and responses. So you can have many hundreds of requests and responses going back and forth within a few seconds to deliver a web page, for example. So if you think of a web page, when that web page is loading, so when you go to www.advancedcareers.uk.com, that call goes off to a server. That server then goes to a series of applications through API, and then that will return back various portions of the page, images, menu, and any login functionality and everything, and it'll start to build that page up using the API. And any articles that are presented in that initial call will then start loading. So the three main ways that APIs are important for businesses that they save a huge amount of time. So for example, if you've ever logged into an application like Facebook, it's an API that will save the time. If you need to create an account, it's an API that is actually creating that account for you. And it saves the company from creating systems from scratch. So if they want to add a new piece of functionality, they can just go off and create another little application, and then that application can communicate with the other applications around it over an API. So that means that it's a lot cheaper to do, and it means the system is more flexible and the system can scale out a lot quicker and easier. Businesses will create apps that rely on APIs, and one of the most famous companies which is built pretty much on the foundation of APIs is Uber, the ride-sharing app, you know, the taxi app. Without its API connection to Twilio, the messaging, which is a messaging platform, it also connects to Google Maps. Without those two key connections, the company wouldn't exist, because it uses Twilio to handle all the messaging to and from their app on the customer's phone back to their drivers, and it uses the Google Maps to display the distance between your driver and you, and also from you to your destination once you're in the car. So APIs do help businesses and can allow businesses from startups to giant corporations to focus on their core competencies without having to do work that has already been done. So you're not having to repeat anything. You can build a little API, a little application, and then let that run. So the future of software, as you can see from what we said here, is it's heavily relying on API. A company like Uber, as we've described, that is built, you know, purely on APIs and is utilizing the applications of other companies, has turned its simple offering of a cab service into a multi-billion-pound business in a matter of years. And that's all down to the basics of you know, APIs that are out there for anyone to latch onto. So with this all this codependence, it opens up lots of opportunities for different applications to integrate with other applications, and it allows developers and technology to to actually advance a lot faster because they don't have to reinvent the wheel. There's often another application or service out there which has an API that you can contact and utilize, as long as you follow the rules that they may have. So one of the best things that it'll do, it'll sparks innovation, creativity, new ways to build, new ways to progress. It's actually removed the need for having intellectual property rights. So it's turned it more into an open source environment. There's currently more than 16,000 public APIs available at this precise moment that you can access, and they're available everywhere from most big companies, small companies alike. And the way that technology is advancing and the way that this industry has embraced the use of APIs, we can see that doubling, quadrupling over the next few years. So it'll just be loads and loads out there that you can do. So APIs are a good thing. They allow us to be innovative, adaptable. They allow us to scale. They allow us to be more economical as well. So API economy, just want to touch on that. It's a general term. It's not something that is often spoken of. It's just something that describes how APIs positively affect organizations' profitability. A prime example, again, go back to people like Uber, Amazon, Facebook, Twitter, all these big organizations that have utilized other applications by the use of an API to make themselves bigger and stronger.
Compare sites as well.
Compare sites as well, yes. Go Compare, insurance supermarket and money supermarket, any sort of like comparison website uses APIs just to share data and to not have to do all of the maintenance of the back-end systems. That's down to someone else. I often used to refer to APIs as a broker because I used to work in the insurance industry. So the API I used to describe as the middleman that will take the request from person A and then go out and find the best results for that request. API management. So that helps us to provide some core competencies to ensure that API programs through developer engagement, business insights, security protection are all in place and managed. A good one is to use is your API management, which takes it'll allow you to take any backend service and quickly launch it as a full-based API program.
I can hear you.
Can anyone else hear me? Do that.
I can hear you loud and clear.
I can hear you.
Okay, thank you. So API management is yep. Okay, so API management is a service provided primarily by Azure, which helps organizations publish the APIs to external.
Can anyone hear Paul or hear me?
I can hear you, David. I can hear everyone.
David, we can hear you, and also Paul.
Yes, I can hear you, Paul.
I think David is having trouble hearing.
I can hear you.
We can
Paul.
hear you.
I can hear you.
David, can you hear us?
Hello, Paul.
Hello, David. Can you hear us? I'm going to continue. Okay, so API management is
Paul,
a
I think
service.
given that the call is recorded anyway.
Yes, and I would like to edit it, but yeah. So I'll continue. So and then we'll have questions in a few minutes anyway. So anyway, API management. It's a service that's provided by Azure. Azure I refer to quite a bit once you get to know me, because I work very heavily with Azure applications and services. What API management does is it helps companies to publish APIs to external companies, partners, or internal developers within your company, and that helps them to unlock the potential of their data and their services. It consists of a gateway. You can set up security protocols, so you can use API keys, which need to be provided to external people who can then use that to access the data that you're providing, and it allows logs to be created and stored. You can go back and see where problems have arise through that transfer of data. So they're very sorry, that's big. So they are very it's a very useful tool to help you better manage the API and all of the security and insights and everything around it that comes with it. So that's the end of the talk today. We're open for questions. Either myself, David, or Solomon, our in-house developer, will do our best to answer your questions. I thank you for your patience. Don't have anything more to say, but at the end of this slide, there is some reference material which will give you more examples of API codes and things there. So I'll share that afterwards. But if anyone has any questions, please ask.
Can I go first, if you don't mind?
Yes, you can. Of course you can.
Okay, thanks, Paul. That was wonderful, short and straight to the point, and I think I got quite a lot from there. So my question is this: I'm working on a project, and quite a lot of the time, the technical, like developers and technical BAs, make references to a lot of API calls. So is it, as an example, is it that if somebody logs onto a website, for example, a customer logs onto a website, does an API now go and talk to another program in another system or database to retrieve that person's contact details once that person has put in their inputted their email address and their password? Does the API now talk to another system to retrieve the information that goes back into that customer portal page or that login page to say, I am who I am, and it verifies me to be able to allow me to now log into the system? Is that the purpose of an API based on what you said earlier?
Yeah, an API, I mean, when you log on, it's allowing for the transfer of the login information off to a different application, commonly a database, and that makes several, with the information sent through it, several things happen. It will have to go through a security layer, so it authenticates your details, and then once it's authenticated that, it will then grant you access. When it authenticates you as a valid user, it will return the logged in page as an example, and in that logged in page you may have various permissions. So as part of the response the request, when you've sent in that request to log in, it's number one, authenticated that you're a valid user. It's also looking up maybe on different tables or different services to see what information you have access to. Now that could
Like
be
role access date.
Yeah, it could be that you maybe have access to view the admin page, but it might not allow you to actually edit some details unless you've paid a more premium. But what I'm trying to get at is that initial call could just talk to one application, or it may talk to many applications. Yeah. So there could be an application that will authenticate your login, and there may be another application that will identify the permissions, yeah, and access and that. So yeah.
Okay. Thank you very much. That was really helpful. Thank you, Paul.
It's okay.
Okay.
Any other questions?
Hello? Yeah.
Hello.
Hi. Oops.
Hello.
Hi. Can you hear me?
Yes.
Hi, Paul. Sorry, I was sorry, guys. For whatever reason, I just couldn't hear anymore. But it was still going on well.
Yeah.
So, sorry, did you have a question?
I have a question. I don't know. I thought someone else was talking.
No, Lanyan, is it?
Yes. Yeah. Okay.
Please ask away.
Okay. From my experience, I've noticed that most of the APIs that my technical team normally work with are the REST APIs. From what you've said, it's clear that there are various types of APIs, but I just want to know the reason why the REST APIs are the ones that are mostly used.
Solomon, do you want to step in on that one?
Can I go first?
I thought, yeah, no, I thought it'd be nice for an actual developer to give a response, but I'm not sure if he's on.
Hello, can you hear me?
Yeah, we can hear you.
Yes.
Okay. Sorry, I wasn't really hearing very well. What's the question again?
So the question, or do you want to ask again, Lanyan?
Yes. Yeah, I was saying that with most of the technical teams I've worked with, most times they usually use the REST APIs, and I mean when I was listening to this call just now, I did realize that there are quite a few types of APIs. I was very much aware of that, but I just want to know why the REST APIs are the most preferred, types of API that are in common usage.
Okay. Basically, I'll put it this way for you. You see, let me give you. Hello.
Please
can you hear me?
Talk. Yes, we can hear you.
Okay. Basically, let me give you a clear picture of what an API does. Let's say, for example, an application will likely be working on, which is like the barber service, where he can take in requests and then cancel requests and stuff like that. Let's say there are certain functionalities we want to include inside. Let's say, for example, you want to be able to send SMSs to clients and stuff like that. So in a situation like that, you wouldn't want to go to the extent of like, okay, you want to build your own SMS sending client, as in sending system and stuff like that. So you could easily go out there and look for, okay, where can you get an API that can easily send messages and stuff like that for you? There are so many of them online. You can pay for their services and then they send you the codes or whatever, all the methods or the functions you can actually perform. And then you can easily make such transactions through that. So I don't know if that answers your question.
Well, maybe my interpretation of your answer is that the REST APIs seem to be the publicly available ones.
Yeah, most APIs are actually built using the REST based on its reliability, and then the cross-platform ability, as in someone can build an API via Java, and then you, a .NET developer, you can still use that same API from your own side, not necessarily using Java to actually interact with it.
Okay, so can an in-house developer, let's say I'm working on a project where there are different products within an organization.
Okay.
If we need those two products to be communicating with each other, maybe I need to be retrieving reports from one product onto the other for maybe analytics purposes. What happens most times is the developers would build an in-house API. Would that be classed as a REST API as well?
You know, when developing applications, for example, you said you might have two products that might need to communicate with each other.
Yeah.
You necessarily might not really need an API for that to be done. So basically, the essence of actually coming up with an API, let's say, for example, you're building an app that you want to accept payments, for example, you want to accept credit card payments and stuff. You won't want to go that extent, like developing a credit card payment. It's quite expensive and stuff. So you can easily, let's say, for example, if you're in Nigeria, you know, there's Quick Teller, you could just pay them to have access to their API for you to use. So when it comes to internal communications, let's say, for example, you want to be able to receive information like analytics and all the stuff, you basically might not really need an API for that. Though you can actually do that in the sense that you can actually reuse it much later, or there are other apps that you might want to really take data from that. An API might really go well with that.
Okay, all right.
If I may add to that, you said the question goes by why REST API are being used more.
Yes.
So the flexibility of using REST API to SOAP API, which are the web APIs. All right. SOAP API is quite standardized. It uses two languages to communicate. But with that SOAP API, it uses two languages to communicate. But with REST API, it uses HTML, JSON, URL, XML. Even with the SOAP API, which uses HTTP and XML only. So there's more flexibility using REST than using SOAP, which are the two web APIs. All right. So you can it's more convenient with JavaScript as well, which is front-end development side of applications. So it is the key thing is the flexibility. Both are, and you know, REST stands for representative state transfer. So each time you make requests, it gives you the latest information. It is quicker.
Yes. Okay. All right. I think it makes a lot of sense now, especially when you said something about Java, because most of the calls that we make they retrieve JSON scripts. So I think all right. Okay.
So
all right.
JSON
Thanks
is
very
only
much.
available to REST, not available to SOAP.
Yeah. Okay. Thank you very much. Cheers.
You're welcome.
Thank you.
Any more questions?
Hi. Yeah, it's Mercy. I would like to ask, what is the relationship between a webhook and an API?
Sorry, come again. A webhook and an API. Come again.
Yeah, what is the relationship between a webhook and an API?
Okay. Webhook.
Webhook.
Sorry, I don't know. Can you rephrase it again? I'm not really.
All right. So an API with an API, you can place a call, and you don't need to know whether there's any data to update or whether there's going to be a response or not. But with a webhook, it will receive a call through the HTTP post from external systems only when there's been some updates. So the webhook relies on the applications that it's connected to send them updates, whereas an API will place a call. It will make a call and it will wait for a response. Yeah. So think about, let's say you want to make a phone call. Yeah. So you're the API. You're going to make a phone call, but you don't know if someone's going to pick it up at the other end. Yeah. Whereas a webhook is the answer phone waiting for a call to come in so it can then record the call. So the webhook is where it's waiting for a call to come, and an API is when you're making a call and waiting for a response. Does that make it a bit simpler?
Yeah, thank you.
Solomon, did I do a good job in giving an example on that?
Yeah, sure you did. You did.
You did an amazing job, Paul.
Thank you.
Sure
That's
you
how I
did.
always remember it. It's like a telephone call.
That's the
Any other questions?
Yeah, sorry. When you're doing your presentation, I saw something like get post. I want to understand what that means.
Let's just go back. What
That's
was
the
it?
API verbs.
API what?
Verb.
Yeah.
Actions.
Okay. Yeah. Something like.
Tell me.
Solomon, you can quick. There are different type of calls. Okay. There are
Okay,
different
he
type
made
of
it.
calls to
Okay.
API. Yeah.
Okay,
You just
I should
ask
come
the
in.
next
Yeah. So
slide.
it's just about the calls you make to APIs. Basically, Solomon, you can call me
You know,
while Paul is doing that. I don't think we. Yeah.
okay, when you want to make a call to an API, there are certain protocols you use. So like the get method now, you actually use it to actually retrieve information from, obviously, the API resides on the server somewhere. The API is actually an application running on the server. And if you really want to get a clear picture of an API, it's just like an application sitting somewhere that performs certain functions. Let's say, for example, you have a payment API residing on the system that does three things: send, receive, and transfer. So when you're making a call to the API, you could either use the get or the post method to actually make a request to the server where that API resides. So you could either call either of those methods, or you could send parameters. It depends on, definitely you'll be given criteria on how to access that API. You could either use query strings, or you could either call some of the methods directly from that API. So whichever way, you could actually use the get or the post method to actually retrieve information from that server where the API resides.
Yeah, thanks, Solomon. Let me add to that. Me, I'm the mini techie and mini business, so I understand my students. Chris, remember during the BA class, I spoke about the CRUD when it comes to database: create, update, read, and delete.
Yeah.
Okay. So those calls, as Solomon was saying, that we have the get, the put, we have delete, we have option, but they are performing those four major functions on a database. So get is basically, I believe get is read.
It's read, yeah.
Yes. Then put is create. You have update directly, which is you update. No, put
is update or
update.
change.
Put is update.
Yeah.
Put is update. Then we have delete, which is obviously delete directly. Okay, so the request you are always making, either you are requesting for information, you are creating new information, or you are updating an existing information. Let's say, for instance, my Facebook page, I go and I create a new post with my image. That is create. And from the user interface, it links through the API to store the information in the database, a separate application. Now, if I want to go and edit that same post I created, the request will now be put. It will not update it. So that is the language. That is API language. All right.
Okay. So you make a different request depending on what the kind of information you want.
Yes.
You create or you delete or you post. Depending on what you want to do on database, basically.
Exactly.
That will determine the request you make.
Yes. Yes.
Okay.
So that is the API version of the CRUD for database, its own language. So it's called API verb, which is like action words.
Thank you very much.
You're welcome.
Any other questions for the panel? Okay, that's cool. Well, that brings us to the end of our session today. I hope everyone found it useful. We will make the recording available after it was stopped.
Hello.
Hello.
Please, can I ask a question, please?
Of course you can.
Like the Uber, like the case study you used about the Uber, how do you get your own percentage? How does the API get their own percentage? Is it every time when we book the Uber, they have their own percentage, or how does it work?
So how does Uber make its money? So what?
Yeah.
By
Is it at the when you want to build the Uber app for them, when you want to be the intermediary in between the customer and the owner of the Uber, are you going to get your money at once, or you get your percentage when people are booking?
So Uber's financial obligations to Google and Twilio are obviously private, but generally you can buy these services. Google allow free use of their Google Maps API up to a certain point. Twilio provide a range of different services for different pricing. So as long as you pay your bill, you can integrate it. The APIs are generally there for free for basic use, but when you want to use it for more, you have to look at the terms of use and the pricing policies that each of these providers supply. So it's like anything, you pay for a monthly premium or a yearly premium to use a service, and you may be able to use it as many times as you want, or there may be a limit on or limitations on the number of API calls that are made to their service, depending on the volume of traffic that's hitting their servers, because you still need to think about infrastructure costs and being able to provide more resource to accommodate any increase in demand. So it's normally billed on a monthly or annual basis. But yeah, so I mean, but the intricacies are normally, when you get to that sort of level, there's normally a deal that's done behind closed doors between the two companies or three companies. So, but if you wanted to go and do something now, you'd more likely, using those services, you'd more likely get part of it for free, depending on the volume, and you probably have to pay for something like Twilio anyway, which isn't really that expensive, but it is a very powerful tool. I use it myself.
Okay. All right. Thank you very much.
You're welcome.
Yeah. Hello, Paul.
Hello.
Yeah, this is Swami. I just want to ask a question, please. Can I do that, please?
Yeah, of course you can.
Yeah, you talk about API, and I'm thinking about inscription. There's some app that have inscription, and if you want to integrate it to another app, does this ensure inscription end to end, please? Inscription, just like security.
Yeah, encryption. So yeah, so a lot of there's some basic best practices that are followed around security protocols, and a lot of these APIs are available on one of the many cloud platforms that are available. Top ones being Google, Azure, and Amazon, and all of these guarantee security, and they do. But the individual APIs will have encryption layers themselves. So it's down to the individual APIs, but a lot of the providers out there will make sure that any data being transferred is encrypted. They have to for GDPR rules. And they not just how that information transfers, but whether it's stored anywhere, even if it stops for a few seconds or a few milliseconds, what's the safety around that? But end-to-end encryption don't always assume that's in place.
Okay, yeah, thank you.
Can I add to that? Okay, well, you know, when you talk about encryption, most especially when you're talking about a web API, there are certain certificates that most of these companies purchase, like we call them SSL certificates. And this ensures that every interaction, both end to end, everything is encrypted, and then you ensure that everything is secured. So in terms of security, I think most APIs do have that.
You're right, most do, but never assume. Is all I'm saying.
Okay.
Oh, thank you, Paul and Solomon.
Thank you, Solomon, for that.
Okay, thank you.
Okay, are there any other questions? We'll take a couple more.
Yeah, hello.
Hello.
Yeah, this is Chris. Yeah. I thought I just want to just confirm if you mentioned that we're going to get the materials or so, because I came in very late and I was just wishing I could. I wish I knew on time. I was just saying I would have joined much earlier, because this API lesson is very, very important to me. Yeah.
Okay, well, it's a presentation that just gives you a basic overview. It's been recorded. We'll share that out, or David will share that out after the session's completed.
Oh, that would be lovely. Yeah, thank you.
Thank you.
Yeah. Thanks.
Okay, we've got time for one more question. Okay. Okay, we'll call it an end there. David, if you want to stop recording.
All right, yeah. Thank you everyone for joining. This is a monthly tech talk. We're gonna be holding the next one first Monday of June. So it's every first Monday of the month. Now, if you have a specific topic that you have been bothering you and you want us to look into it, feel free to drop me a direct message, or if you are on our general group platform, drop a message on the general group. Then I and Paul will discuss and then select a candidate for the next tech talk. All right. And as I said in the beginning, this is to enhance your skills and your knowledge, so that when you come across this technical stuff in your career, for those that have not started working, it will not be something completely new to you. All right. Thank you everyone for joining. Until next time, do have a lovely night rest. Bye.
Thank you.
Thank you. Bye.
Thank you very much.
Thank
you very much.
Thank you, David. Thank you, Paul. Thank you, everyone. Bye.
Thank you.
Thank you. Bye.
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 Thank you and bye.
Bye.